in this video, we are going to talk about the derivatives of hyperbolic functions. So for example, let's assume that we are given the function y is equal to hyperbolic sine of x. What is y prime? So now, what we need to do is that we need to define the hyperbolic sine. So in other words, y is equal to sine x is giving us half exponent x, then minus exponent minus x. So now y prime is equal to half, then we will differentiate what is inside the bracket. So if you differentiate exponent x, you will get back exponent x. Then now if you differentiate minus exponent minus x, you differentiate what is on top, so this becomes minus. Then if you differentiate minus x, you get minus 1. Then if you differentiate the whole function, you get back exponent minus x. So now y prime is equal to half, then exponent x becomes exponent x, then minus 1 times minus 1 becomes plus 1. So plus exponent minus x. Now what is this? Now exponent x, half of exponent x plus exponent minus x is the cos function. So y prime is equal to cos x. So this implies that anytime you differentiate hyperbolic sine of a function, you are going to get the hyperbolic cos of the same function. So therefore d dx of sin x is equal to cos x. Now, what if y is equal to cos x? Then what is y prime? So we are going to use that same idea to differentiate sin x. So in this case too, we need to define the hyperbolic cosine function. So we say that y is equal to half into bracket exponent x plus exponent minus x, bracket close. So from here, y prime is equal to, if you differentiate, so we bring half out. If you differentiate exponent x, it's the same as exponent x. If you differentiate exponent minus x, you need to differentiate minus x. If you differentiate minus x, you get minus 1. So minus 1 times, if you differentiate exponent minus x, you get exponent minus x, then bracket close. So y prime is equal to half of, now into bracket, exponent x, then minus exponent minus x. Now look at this. This is what sin x is half of exponent x minus exponent minus x. And here's y prime equals half exponent x minus exponent minus x. It implies that y prime is equal to the hyperbolic sine of x. So in other words, when you differentiate d dx of hyperbolic cos x is equal to the hyperbolic sin x. So now, using the same idea, let's if y is equal to hyperbolic tan x, then what is y prime? So now we know that y is equal to tan x is the same as hyperbolic sine x divided by hyperbolic cos x. Then y prime is equal to, in this case we need to use the quotient rule. So you maintain the denominator, which is cos x, then you differentiate the numerator. If you differentiate sin x, you are going to get cos x, then subtract it from, maintain the numerator, which is sin x, then differentiate the denominator. If you differentiate cos x, you are going to get sin x, then you divide it by the square of the denominator, which becomes cos squared x. So y prime is equal to cos x times cos x is cos squared x, then minus sin x times sin x becomes sin squared x, then divided by cos squared x. But remember that from the identities that we have already proven, we proved that cos squared x and minus sin squared x is equal to 1. This is the equation for the unit hyperbolic function, and therefore all of this numerator becomes 1. Therefore y prime is equal to 1 divided by cos squared x, and then 1 divided by cos squared x is equal to the sec function. So this is sec squared x. Now, what if y is equal to sec x? Then what is the derivative of sec x? So now what we need to do is to express sec x. So y is equal to sec x is the same as 1 over cos x. So in this case too, we need to use the quotient rule, and therefore y prime is equal to maintain the denominator, which is cos x, then differentiate the numerator. If you differentiate 1 is a constant, so it's 0, then minus maintain 1 and differentiate the denominator. You differentiate cos x, you get sin x, then you divide it by the square of the numerator, so cos squared x. So y prime is equal to, so here becomes 0 minus sin x divided by cos squared x. So y prime is equal to minus sin x, then divided by cos squared x can be written as cos x, then times 1 divided by cos x. So now y prime is equal to minus sin x over cos x. Remember, we said tan x is sin x over cos x. So that will give us hyperbolic term, so tan x. Then 1 over cos x is sec x. So this becomes the hyperbolic sec x. What if y is giving us cosec x? Then what is y prime? What is the derivative of cosec x? So just as we did previously, y is equal to cosec x is the same as 1 over sin x. So y prime is equal to maintain the denominator, which is sin x, differentiate the numerator. If you differentiate 1 is 0, minus maintain 1, then you differentiate the denominator. If you differentiate sin x, you are going to get cos x. Then you divide it by the square of the denominator, which is sin squared x. So y prime is equal to, now this becomes 0, then minus 1 times cos x, it becomes minus cos x divided by then sin squared x. So y prime is equal to minus, then I'm writing here as cos x over sin x, and times 1 divided by sin x. So y prime is equal to minus cos x over sin x is the inverse of tan x, and 1 over tan x is the cot x. So here is minus cot x, then 1 over sin x is the cosec, so cosec x. So if you differentiate cosec x, you are going to get minus cot x, then cosec x. Now let's assume y is equal to cot x. Then what is the differential of cot x? So just as we did previously, y in this case, cot x is the same as cos x divided by sin x. So y prime is equal to Maintain the denominator. We are using quotient rule. Sin x, differentiate the numerator. You differentiate cos x, you will also get sin x. Then minus, maintain the numerator, which is cos x. Then differentiate the denominator. If you differentiate sin x, you get cos x. Then you divide it by the square of the denominator. So y prime is equal to sin x times sin x is sin squared x. Then minus cos x times cos x is cos squared x. Then divided by sin squared x. Now, I want to pull out minus 1. So y prime is equal to, if I pull out minus 1, so let me just pull out minus. So cos squared minus cos squared x will become cos squared x. Then plus sin squared x becomes minus sin squared x divided by sin squared x. So y prime is equal to, now cos squared x minus sin squared x is equal to 1. So here becomes minus 1 divided by sin squared x. Now y prime is equal to minus 1 over sin squared x is the cosec. So this becomes minus cosec, hyperbolic cosec. So hyperbolic cosec squared x. So if you differentiate cot x, you are going to get minus hyperbolic cosec squared. Let's talk about the derivatives of the inverse hyperbolic functions. So what if instead of cos x, we are given y equals to cos inverse of x? What is the derivative of cos inverse of x? So now, in this case, if y is equal to cos inverse of x, it means that cos y is equal to x. So we are going to use implicit differentiation here. So what we will do is that you differentiate y. If you differentiate y, you get y prime. And if you differentiate cos y, remember, if you differentiate the cos function, you get the sin function. So this becomes y prime sin y equals x. So y prime is equal to, if you differentiate x, you will get 1. So y prime is equal to 1 divided by sin y. But then we know that cos squared y minus sin squared y is equal to 1. So making sin y the subject, if we bring sin here and we take 1 over there, then we are going to see that sin y is going to give us square root of cos squared y minus 1. So y prime is equal to 1 divided by square root of cos squared y minus 1. Now, remember we said that cos y is equal to x. So cos squared y is going to give us x squared. And therefore y prime is equal to 1 divided by square root of square root of x squared minus 1. But we need to determine the domain of this function. And this function is not defined everywhere. It is only defined where the magnitude of x is greater than 1. What if y is equal to the hyperbolic sine inverse of x? Then what is y prime? So if y is equal to sine inverse of x, it means that sin y is equal to x. So in this case, we will use the implicit differentiation. So you differentiate y, you get y prime. You differentiate sin y, you get cos y. And if you differentiate x, you get 1. So y prime is equal to 1 divided by cos y. Now, from this equation, we can make cos y the subject. We know that cos y is equal to the square root of 1 plus sine squared y. So y prime is equal to 1 divided by square root of 1 plus sine squared y. So now, we've said that sine y is equal to x. So sine squared y is x squared, and therefore y prime is equal to 1 divided by square root of 1 plus x squared. Now, this function is defined everywhere, and therefore the domain is x is just a member of real numbers. Any value of x you put in this function, you are going to get a corresponding value of y. If y is equal to a hyperbolic tan inverse of x, so what is y prime? Now, using the same principle, if y is equal to tan inverse of x, it implies that hyperbolic tan y is equal to x. So using implicit differentiation, if you differentiate y, you get y prime. And then if you differentiate tan y, you are going to get hyperbolic sec squared y. And then this is equal to, if you differentiate x, you get 1. So y prime is equal to 1 divided by sec squared y. Now, we need to use a certain identity. Now, let's prove something. We know that cos squared y minus sin squared y is equal to 1. So if we divide through by cos squared y, let's divide through by cos squared y. Divide here too by cos squared y. So at the end of the day, you will see that this becomes, here will become 1, then minus sin squared y divided by cos squared y is the hyperbolic tan. So tan squared y. Then this is equal to 1 over cos squared y is the sec squared y. So in other words, sec squared y can be written as 1 minus hyperbolic tan squared y. And therefore, y prime is equal to 1 divided by 1 minus the hyperbolic tan squared y. But we've said that hyperbolic tan y is x, so hyperbolic tan squared y is x squared, and therefore this is equal to 1 divided by 1 minus x squared. But to determine the domain, we know that the magnitude of x should not be equal to 1. Now, let's talk about how to express hyperbolic functions as logarithmic functions. So, for example, hyperbolic sine inverse of x is equal to ln into bracket x plus square root of x squared plus 1 for all x being real numbers. So this is very important statement. So now, what we are supposed to do is, we are supposed to prove why this is true. So now, what we will do is that, let's let a to be equal to the hyperbolic sine inverse of x. So if a is equal to hyperbolic sine inverse of x, it implies that hyperbolic sine of a is equal to x. Now let's or in other words, x is equal to the hyperbolic sine of a. Now we have established that hyperbolic sine of a can be written as half of exponent a, then minus exponent minus a. So it implies that x is equal to half of, into bracket, exponent a, then minus exponent minus a, bracket close. So let's multiply through by 2. So this becomes 2x is equal to exponent a minus exponent minus a. Now let's multiply through by exponent a. So we want to multiply by exponent a. So here becomes 2x exponent a, then this is equal to exponent a times exponent a will give us exponent 2a, and then minus exponent minus a times exponent a will give us exponent 0. So this will give us, now I want to bring all the equation to the right hand side. So this becomes exponent 2a, then if I bring this one here, it becomes minus 2x exponent a, then exponent 0 is 1, so it becomes minus 1. Now let me rewrite this equation well. So this will become exponent a all squared is the same as exponent 2a. So exponent a all squared minus 2x exponent a, then minus 1 is equal to 0. Now we want to let exponent a to be equal to capital B, or b is equal to exponent. So this implies that b is equal to exponent capital A. So this equation then becomes b squared minus 2xb minus 1 is equal to 0. So now you see that this equation is of the form ax squared then plus bx plus c is equal to 0. So we can use the quadratic formulas to solve for b. You know that from here x is equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a, and this is the quadratic formula. So now in this case our b becomes minus b, so the coefficient of b is minus 2x, so minus 2x becomes 2x, then plus or minus square root of b squared, so minus 2x squared minus 4a. The coefficient of b squared is 1, so 1 times c minus 1 all divided by 2 times a, so 2 times 1. So b is equal to 2x, then plus or minus square root of minus 2 squared is 4x, sorry, minus 2x squared is 4x squared, then minus 4 times 1 is minus 4 times minus 1 becomes plus 4 divided by 2. So what we can do here is we can factorize. Let's factorize 4 out of this square root. So this becomes 2x plus or minus. Now if you factorize 4, square root of 4 is 2, so 2 root x squared plus 1 all divided by 2. So now let me continue from here. You can see that if you divide through by 2, b is equal to 2x plus or minus square root of x squared plus, so let me rewrite it, b is equal to 2x plus or minus square root of x squared plus 1. Now you can see that we have gotten everything which is inside the len bracket. Now this b, because we are going to take logarithms, remember that we said b is equal to what? B is equal to exponent a. So let me do that here. B is equal to exponent a, so it implies that exponent a is equal to this result, which is 2x plus or minus square root of x squared plus 1. Now if you take logarithms on both sides, a is equal to ln e, and ln e is 1. So a is equal to ln into bracket 2x plus or minus square root of x squared plus 1. But because we cannot have logarithm of a negative number, now square root of x squared plus 1, sorry, I made a mistake. The result we got was not 2x, it is x plus or minus square root of x squared plus 1, because remember we divided through by 2 over here, so we need to drop the 2. So it is ln x plus or minus square root of x squared plus 1. But then you can see that square root of x squared plus 1 is always greater than x, and therefore since it is always greater than x, we cannot take the negative value of this, else it will send us into the negative values, and we don't have the natural log of a negative value. It is undefined, and therefore we can only take positive values. So at the end of the day, writing the final result, a is equal to natural log of x plus square root of x squared plus 1. So we have been able to prove, remember that we said that sine a is equal to x, so a is the same as what? Sine inverse of what? X, and therefore we have been able to prove that sine inverse of x is equal to natural log of x plus square root of x squared plus 1. Now we want to also prove that the hyperbolic tan inverse of x is equal to half the natural log of, into bracket, 1 plus x divided by 1 minus x for all x such that the magnitude of x is less than 1. Now, just as we did for the previous example, in this case too, let's let a to be equal to tan inverse, hyperbolic tan inverse of x. So it implies that tan a, hyperbolic tan a, is equal to x. So now all we need to do is to use the definition of tan a. So x is equal to, by definition, tan a is giving us exponent 2a then minus 1 divided by exponent 2a plus 1. So this is the definition of the tan. So now let's cross multiply. So it becomes x times exponent 2a plus 1 bracket close equals exponent 2a minus 1. So let's expand the bracket. This becomes x exponent 2a then plus x equals exponent 2a then minus 1. Now let's take all the exponent 2a to one side, then the exponent, then the other terms to the other side. So we are going to take minus 1 to this side, so it becomes 1 plus x equals exponent 2a then minus x exponent 2a. So we can then factorize exponent 2a out. So if we factorize exponent 2a out, we are going to be left 1 minus x, and this is equal to 1 plus x. So let's divide through by 1 minus x. If you divide through by 1 minus x, here too by 1 minus x, this one and this one will cancel. So we will find out that exponent 2a is equal to 1 plus x divided by 1 minus x. To proceed from here, we need to take the natural log of both sides. So natural log of exponent 2a is equal to natural log of 1 plus x divided by 1 minus x. So you can see that we have gotten this side. So this becomes 2a then ln e, but ln e is 1 equals natural log of 1 plus x divided by 1 minus x. So now let's divide through by 2. Now ln e is 1, so we can say that a is equal to 1 over 2 natural log of 2 bracket 1 plus x divided by 1 minus x. But what did we say was a? A is hyperbolic tan inverse of x. So it implies that hyperbolic tan inverse of x is equal to half of natural log of 1 plus x divided by 1 minus x. So we have also been able to prove that this relationship is also true. Finally, let's prove that hyperbolic cosec inverse of x is equal to natural log of into bracket 1 divided by x plus square root of 1 plus x squared divided by the absolute value of x. So just as we did for the previous example, so let's let capital A to be equal to the cosec inverse of x. So it implies that x is equal to the cosec A. So now cosec A is the same as 1 divided by hyperbolic sine of A. So x is equal to 1 divided by sine A. Now let's do the definition of sine A. So x is equal to 1 divided by sine A is the same as half of into bracket exponent A minus exponent minus A. So x is equal to, these two will go to the numerator, so 2 divided by exponent A minus exponent minus A. So now what we'll do is that we'll cross multiply, and then if we cross multiply, we are going to get x times exponent A minus exponent minus A equals to 2. So let's expand this bracket. So this becomes x times exponent A, then minus x times exponent minus A, and that is equal to 2. Now let's multiply through by exponent A. So this becomes x exponent 2a, then minus x times exponent minus a times exponent a becomes exponent 0. This is equal to 2 times exponent a. So x exponent 2a then minus x is equal to 2 exponent a. Now let's bring everything to the left hand side of the equation and then rewrite this as x times exponent a all squared, then minus 2 exponent a, then minus x equals 0. So let's let capital B to be equal to exponent a. So this becomes bx x b squared, then minus 2b minus x equals 0. So you see that this equation is also a quadratic equation. It's of the form ax squared plus bx plus c equals 0. So we can use the quadratic formula, and therefore at the end of the day b is going to be equal to minus b. So minus minus 2 plus or minus square root of b squared, which is minus 2 squared, minus 4ac. A is x and then c is minus x, then all over 2a, so all over 2 times x. So b is equal to 2 plus or minus square root of minus 2 squared is 4, then plus 4x squared divided by 2x. So b is going to be equal to, now 2 divided by 2x is 1 over x plus or minus square root of, now if we factorize 4 here, we are going to, and square root of 4 is 2, and 2 divided by 2 is 1. So here we'll be left with square root of 1 plus x squared divided by x. So proceeding from where we left off, we reach the place where we said b is equal to 1 divided by x plus or minus square root of 1 plus x squared divided by x. But then we said that b was equal to exponent a, and therefore exponent a is equal to 1 divided by x plus or minus square root of 1 plus x squared, then divided by x. But now, you see that square root of 1 plus x squared divided by x is always going to be greater than 1 divided by x. And therefore, we cannot take the negative value of this. And therefore, we are always going to get exponent x equals 1 divided by x, then plus square root of 1 plus x squared divided by. Now, here we need to place absolute value of x. The reason is because immediately x is negative, then we are going to get this 1 over x to be greater than this whole term. 1 over x is greater than root 1 plus x squared divided by x if x is less than 0. So that we will not get that situation, we need to place absolute value here so that x can never be less than 0. And therefore, now from here we can take the natural log. So natural log of exponent a is equal to natural log of, into bracket, 1 over x plus square root of 1 plus x squared divided by absolute value of x. So now, natural log of, so we can bring a down. So a is equal to natural log of e is 1. Natural log of, into bracket, 1 divided by x plus square root of 1 plus x squared divided by the absolute value of x. Now, but we said that a was equal to the cosine inverse of x. So therefore, a is equal to cosec inverse of x, and therefore cosec inverse of x is equal to natural log of 1 over x plus square root of 1 plus x squared divided by absolute value of x.